In this video, we're going to look at tree diagrams. A tree diagram is a simple tool for expressing the probabilities of the outcomes of an event, and it really makes the solution of certain probability problems easy, as you see from some of the examples I'll come. To understand tree diagrams, you need to understand the idea of conditioning of probability. So you need to understand what conditional probabilities are, and I'll just give you a simple reminder. So just assume this is a bag with 7 red balls and 3 blue balls. Okay, now imagine 2 balls are picked, and after the first ball is picked, there is no replacement. So no replacement of the balls. So the question now is what the probability of picking a red ball the second time. And in terms of, and that is easily expressed as follows. You're saying, what's the probability of picking a red ball the second time given, so let me rephrase the question. What's the probability of picking a red ball the second time given that a red ball was chosen the first time? So let's think about it. If a red ball is chosen the first time, it means that there are 6 red balls left. So given this scenario where we've picked a red ball the first time, what's the probability of picking a red ball the second time? Well, there are 6 red balls out of a total of 9 balls. Now, if it was a case where replacement of the balls took place, so if a red ball is chosen, just before moving to the scenario where the balls are actually replaced, let's look at this scenario where balls are not replaced. So we've looked at the probability of picking a red ball the second time given a red ball was chosen the first time. And now let's look at the probability of picking a red ball now. Initially, in this scenario, there are 7 red balls and 3 blue balls. The probability of picking a red ball is simply 7 over 10. There are 7 red balls out of 10 balls. Now, when we're carrying out replacements, again, the probability of picking a red ball is 7 over 10. There are 7 red balls out of 10 balls. But the probability of picking a red ball the second time, given that a red ball was chosen the first time, is what? Well, because there's a replacement of balls, a red ball is chosen the first time, which gives 6 red balls, but it is replaced, which gives 7 red balls. So we have the original scenario again. So what's the probability of picking a red ball, given that a red ball has been chosen the first time? Now, when a red ball has been chosen the first time, one still has 7 red balls and 3 blue balls to pick from. So there are 7 red balls. That's the number of desired outcomes divided by the total number of balls, which is 10. Now, in the scenario where there's no replacement of balls, you can see that the probability of picking a red ball is 7 over 10. The probability of picking a red ball given that a red ball has been chosen already is 6 over 9. As you can see, picking a red ball has an effect the first time, has an effect on picking a red ball the second time. Whereas in this case, picking a red ball the first time doesn't have an effect on picking a red ball the second time. Why? Because the probability of picking a red ball is 7 over 10. And the probability of picking a red ball, even though a red ball has been chosen, is still 7 over 10. In fact, the probability of picking a red ball, given that a blue ball has been chosen, will also be 7 over 10. Why? Because in that scenario, initially you have 7 red balls and 3 blue balls. Now, if a blue ball is chosen the first time, you have 2 blue balls left. But because it's replaced, you have 3 blue balls. So now we've chosen a blue ball. What's the probability of picking a red ball? Well, it's still 7 red balls out of the 10 balls. So as you can see, when there's replacement, conditional probabilities don't really have a major effect, but it's good for you to be aware of how the occurrence of an event can affect the probability of another event, like in this case here, because there's no replacement, probability of picking a red ball changes. It actually depends on whether a red ball has been chosen the first time or not. In fact, in this first scenario, what's the probability of picking a red ball given that a blue ball has been chosen? In this scenario, just draw the box again. If you've chosen a blue ball already and you're not making any replacements, there will only be 2 blue balls left. So the probability of picking a red ball will be 7 divided by 9. As you can see, all these probabilities are different. So the probability of picking a red ball in this case depends on whether a blue ball has been chosen already or a red ball has been chosen already. In the second scenario, probability of picking a red ball is always the same regardless of what has happened before, because there's a replacement of the balls. So this just is a good way to remind you of the idea of a conditional probability. The probability of an event varying or not based on whether other events have occurred in the past.